Welcome to this video of another set of 10 CWI Part A questions. These are random questions with explanations provided that will guide you in your preparation for the CWI exam. So let's not waste any of your time and go into the video.
The size of the weld represented in the figure below. A is not important. B cannot be determined directly from the symbol. C can be determined from the symbol. D is not specified, therefore may be determined by the welder. E must be found in the WPS. In this question, as you can see, the welding symbol does not have any indication of the number at the left of the welding symbol right here. So it doesn't indicate anything. Therefore, the answer here is letter B. The size of the weld cannot be determined in this welding symbol. Letter A does not make sense. Letter C is obviously incorrect. Letter D, if the welding symbol is not clear, the welder will definitely ask for the size here. Letter E, the size of the weld may or may not be found in the WPS. So the answer here is letter B. Welding symbol information provided in the figure below requires A. Field welding, B. Weld all around, C. A fillet weld, D. The use of shielded metal arc welding, letter E. All of the above. You can observe the welding symbol here. So this symbol is the symbol of a fillet weld. This flag right here is a symbol for field welding. The circle right here is, or the circle right here represents weld all around, and the information indicated in the tail is SMAW, which means shielded metal arc welding. So the answer here is letter E. A shielded metal arc welding weld has produced in which the welder failed to properly clean between passes in a multipass weld, which non-destructive test would best reveal the flaws that may be present in the completed weld. ART, BVT, CMT, DPT, letter EET. Since the welder failed to clean passes in between weld in a multipass weld, this indicates that the flaw will likely to have occurred in the subsurface of the weld. Visual tests will have no use in subsurface flaws. You cannot see that by the naked eye. MT and PT are for near surface discontinuities. ET is also for near surface. The only NDT here that can detect subsurface flaw here is RT. Hence, the answer here is letter A, radiographic testing. Which of the following welding techniques below describes a welding process in which the filler metal feeding is machine operated while the joint travel speed and guidance are the responsibility of the welder? Letter A, semi-automatic. Letter B, machine. Letter C, manual. Letter D, automatic. Letter E, mechanized. Machine, mechanized, and automatic welding are synonymous in which every parameter can be done without welder supervision. Hence, machine and mechanized welding have welder operator and not a welder. So because it basically operates a machine. Manual welding, the welder will have to control all parameters including wire feed speed because he basically will replace the electrodes once it was being consumed. Semi-automatic like GMAW, FCAW are the ones that the wire feed speed is operated by a machine. Basically, it is the wire speed is controlled by a reel. Hence, the answer here is letter A, semi-automatic. Arc strikes are discontinuities most commonly associated with A. ESW, B. SAW, C. SMAW, D. OAW, letter E. GMAW. Arc strikes commonly happen in SMAW or stick welding since this is mainly a welder error or a bad habit that the welder do prior striking the weld metal. They strike the surface to test and may lead to this discontinuity. So it is a common welder behavior wherein they strike the surface and thus cause this arc strike discontinuity. A and B are automatic process, so this will not happen. ESW and SAW. OAW is operated by a torch, which likely won't happen. GMAW can have arc strike occur, but not as much as SMAW. So the answer here is letter. So the answer here is letter C, SMAW. Liquid penetrant testing is not recommended when inspecting which of the following metals? Letter A, aluminum plate that has been chemically cleaned. B, steel weld test plates brushed. C, stainless steel pipe as welded by GTAW. D, a casting that has been sandblasted. A and B is okay, and B is even recommended prior dye penetrant testing because basically you have to clean these weld surfaces in order for dye penetrant testing to be accurate. So it basically keeps the opening of the surface which is necessary for capillary action. C is also good since austenitic steel can still be detected by PT. So if you're using magnetic particle testing for austenitic stainless steel, you can do that because it can't be magnetized. The answer here is letter D. Since sandblasting breaks off or pin the surface that can close necessary opening in the surface necessary for capillary action. So if you sandblast the surface of a metal, basically dye penetrant testing will not be possible because you basically broke off all the openings there that is necessary for the capillary action or the liquid coming or rising to the surface to occur. So the answer here is letter D, a casting that has been sandblasted. By the way, I just want to take a break from the video and remind you of the free Udemy course that I've put in the description down below. So it composes of CWI Part A lectures, the introduction for welding inspectors. So you can check out the description below for that free Udemy course. Now back to the video. Which of the following discontinuities is not associated with GTAW? A. Lack of fusion. B. Slag inclusions. C. Tungsten inclusions. D. Porosity. E. Undercut. All of the discontinuities mentioned above can happen to GTAW except slag inclusion. Letter B. Since GTAW is very much a clean welding process with little to no slag produced during the welding process. The answer here is letter B. An E71T-1 electrode designation is for which welding process? Letter A, PAW. Letter B, FCAW. Letter C, SMAW. Letter D, GMAW. Letter E, SAW. So the answer here is letter B. The designation T here means tubular, which is the electrode description for FCAW or flux cord arc welding. So the answer here is letter B. What is meant by the term essential variable? Letter A, data on a WPS that if changed during production will render a WPS disqualified. Letter B, data on an inspection report that if changed render the report disqualified. Letter C, the data on an MTR or material test report that is essential to the chemistry of the material. Letter D, the recommended amperage and voltage for welding as published by the manufacturer. Letter E, describes what should be included in a WPS. So let me run through the choices here. So letter B and C is an automatic elimination of the choices since this essential variable refer to the WPS. WPS can indicate the recommended amps and volts for welding, but this is not the definition of an essential variable. So basically, you can indicate the recommended amperage or voltage from the welding as for welding as published by the manufacturer, but this is not the definition of an essential variable. Letter E, those are not just what's needed to be included in the WPS. So the answer here is letter A. If these essential variables change, then the WPS will be disqualified and you will need to requalify the procedures indicated in the WPS again. So you'll need to retest those procedures that was done or the results of the procedures that was done during the original WPS and the variables that was changed. Where should the preheat temperature be measured? Letter A, in the weld groove. Letter B, 12-inch from the weld groove. Letter C, where the arc will be initiated. Letter D, 2 to 3 inch from the weld groove. Letter E, preheat temperature need not be measured. So the preheat temperature needs to be measured 2 to 3 inch from the weld. So the answer here is letter D. This is because this is where the HAZ or heat affected zone is wherein the highest susceptibility of martensite formation can happen. So what does that mean? So has refers to the portion of the base metal that has been heated to high temperature but not melted. So when it cools off, it basically undergoes the base metal undergoes a microstructural change that can affect its mechanical or material properties such as strength and toughness. So martensite formation can lead to the brittleness of the base metal, which we don't want that. So when no preheat is used, has is relatively narrow and will exhibit the highest hardness. So as a welding inspector, you need to inspect the preheat temperature at the has or in the heat affected zone because this is where the highest brittleness will happen. This is why this is the location where the preheat temperature must be measured to ensure that effective slowing down of the cooling rate happens in the heat affected zone, because essentially that is what preheat does to the base metal. So it slows down the cooling rate of the base metal, hence will slow down also the formation or prevent the formation of martensite, hence prevent brittleness of the base metal.